Hello, this is John from caveofprogramming.com, and this is a tutorial on linked lists in Java. And I'm going to be talking a bit about the list interface, and I'm going to be comparing linked lists with array lists. So I'm in Eclipse as usual, and I've got my main program set up, and I'm going to create an array list to start with. So array list, I'm going to put integers in that list. So I'll create the variable and then I'll say that equals a new array list, and wherever I mention the basic type, I've got to also say what type of thing it contains, integer. And let's also have a linked list containing also integers, linked list, so we can compare the two, linked list, integer. And let's say that I want to pass these lists to a function. So this is one typical use of the list interface. I'll create a method here, let's say private static void, and I'll call it do timings. And this is just gonna be a function that does some timings on my lists. So I'll have a description here called type, a string. And then I want to pass in my list. And to do that, I can just use the list interface parameterized on integer, because that's what's in my lists. I do Control-Shift-O to add the input, and you need Java util list there. So now I can pass any kind of list. Well, strictly speaking, I can pass anything that implements the list interface to this method. So I can say do timings. I'll just put in a descriptive string. I'll say array list. So array list, and I'll pass in the array list, and I can also say do timings linked list, again just a string to describe what it is, linked list, like that. So because both of these implement the list interface, wherever you see a list like this, whether it's a variable or it's an argument or whatever, you can point that quite happily at a linked list or an array list, and that's what you use interfaces for. It's quite handy. And the idea is that when you create the list, you have to think about what type of list you want to use, but afterwards you don't care. So afterwards you could use the common list methods to manipulate the list, just adding items, getting items, and so on. And you really don't care what kind of list it is. So you can kind of abstract the kind of particular type away just using a list. So here I could even have had list as well if I want. In fact, I will, just to show you how to use it. It doesn't matter, and the only bit where you need to think about the particular type of list is here when you actually create the instance of it. Okay, so now the basic rule here is that if you only want to add or remove items at the end of your list, use an array list, and that's the most frequent case. If you want to add or remove items from anywhere else in the list, like the beginning or the middle, use a linked list. And I'll go into the reason for that shortly, but first I just want to show you an example of that. So in do timings, first I'm going to populate my list with let's say 1e5, 1 times 10 to the exponential 5, so that's 100,000 items. And I'll just say list.add, so I'm using the list interface method add here, which you can also find in array list and linked list. And I'll just add in I to add something to add there. So I've populated the list. And then I want to get the time now, because I want to time how long this code takes. So I'll say long start equals system.current time milliseconds. And after I've written some code, I'll have long end equals system.current time milliseconds. And then at the end I'll say sysout time taken and end minus start milliseconds for type. And what that's going to look like is, I missed off a plus here. as if I run this, it's just going to say time taken such and such for array list and such for a linked list. It's going to time whatever I put in here. So let's have a look at adding items to the end of the list. So I'll say for int I equals 0, I less than 1 e5. Hopefully I won't run out of memory here. I might do, but we'll see. And I will just say list.add. So I'm just adding more items in, but I'm adding them at the end of the list. So let's say add items at end of list. And if I run this, it's 13 milliseconds for array list and a bit longer for linked list. But yeah, I ought to mention here that to be honest, for normal size lists, it actually doesn't even matter what kind of list you use, because these timings are not going to be significant. You only really have to worry if you've got lots and lots and lots of items in your list. But by default, usually you just use array list. But you can see that it's a bit slower to add items to a linked list, to add items at the end of a linked list. But let's comment this out now and add items, let's say at the beginning. So add items else were in list. And again, I'll have for int I equals 0, I less than 1 e5 I plus plus. And I'll say list.add. And there's a version of add that takes an index as the first parameter, which is the location where you want to add the item. So here I'm saying add items at the beginning of the list. And if I run that, you'll see it takes a long time to add items to the beginning of an array list. This is probably gonna, yeah, so it took 7, nearly 8 seconds there. But for the linked list, it didn't really make any difference. It just took 78 milliseconds. I can't remember how long it took before now, but I think it was pretty similar. So if you add items to the end of the list, yeah, it's still like 72 milliseconds for the linked list. So the linked list doesn't really care where you add the items, but the array list does. And that's the golden rule to remember, that if you want to add items in the middle or end or wherever of the list, then you need to use linked list. Otherwise, yeah, if it's the beginning or middle of the list, use linked list. If it's the end, use array list. And actually, even if you add items near the end of the list, array list can be more efficient than linked list. So let's say I add here, I could put list.size in here. So this is adding items right to the end. An array list, of course, is faster. But let's say I add items at 100 elements from the end of the list. Array list is still faster. So why is that? I'll explain the difference between the two kinds of lists, and you'll see why you need usually a linked list to add items anywhere other than very close to the end. So an array list internally manages an array. So let's put a comment here. I'm going to put this code on caveofprogramming.com. So you can peruse it at your leisure if you want to. So array lists manage arrays internally. So if you look at the insides of an array list, it's just a bunch of elements stacked next to each other like this, and so on. So traversing the list is very fast. Getting a particular item from the list is very fast. If you want to get an item at position 500 or whatever, it's easy to calculate. It's easy for Java to calculate the position in memory of that item and just go and get it. If you want to add items to the end of the list, it's usually fast, because if you can actually specify an initial size for your array list here, but if you don't, it's going to have an initial size of 10 items. And if you add an 11th item, it will create a new array of, I think, twice the size. So I think it's like 20 items. And copy all the old items into that new array and then put in your new item. So only occasionally does it need to create a new array internally and copy the items to it. So only occasionally does it get a little bit slow. But basically, adding items to the end, removing items to the end, It's usually very fast. But what would you do if you want to add an item to the middle of the list or the beginning? Then you've basically got to move all the following items up one unit, and then you can add the item in. So that's very slow. So because you've got to shift all the items along one step, it takes a long time to add or remove items anywhere other than near the end of the list. Although if it's quite close to the end, then it can still be fast because you've only got to shift up like 2 or 3 items or 100 or whatever, and that's pretty fast. But now a linked list works internally quite differently. So linked lists consist of elements where each element stores, has a reference to the previous and next element. So a linked list internally looks a bit like this, and these arrows are kind of references to the next element, and they also have references to the previous elements as well. So to traverse a linked list can be slower than an array list, and to go and get a particular item at a particular position can be slower, because you've got to traverse the list. You've got to get the first item, get the link to the next item, get that item, get the link to the next item, and so on. It's a slow business. But where a linked list comes into its own is if you want to add an item to the beginning or the middle of the list, because then all you've got to do is, let's say I want to add a new item here. I've just got to point this item at my new item instead of that one, and point this item backwards at my new item instead of pointing it back at this one. And that's relatively fast. So, in a nutshell, just to repeat, use array lists normally, but if you want to add or remove an item in the middle or beginning of the list, anywhere other than near the end, use a linked list. And actually a friend of mine got asked about the difference between these lists on an interview recently. So this kind of question comes up on interviews and exams, and employers or examiners may well expect you to know the difference between how these lists work internally. And it's really pretty simple. Once you understand the basic concept, you'll always know which kind of list to use, and it's pretty straightforward. So that's it for this tutorial, and in the next tutorial we're probably going to look at the next most useful kind of member of the Java collections framework, which in my opinion are the maps, and we're going to start by looking at HashMap. So join me again for that tutorial, and as I say, this code's on caveofprogramming.com, and until next time, happy coding.